A mysteriously simple integral. So in this video we have an integral from 0 to 1 of li z dz, and the small li function is basically defined as the integral from 0 to z of 1 by ln x dx. Yeah, and so with this definition of this function we will be able to find its integral from 0 to 1, and let us see how this goes. So first of all, let us write its definition over here. Integral from 0 to z of 1 by ln of x dx. Yes. Now, on its own, like in the same way as it is, it really won't be easy enough to solve. Even if we make substitutions like y equals ln of x, it is just modified to some other non-elementary functions, yeah, and that will still remain complex. So this will require kind of a special idea or the special technique of introducing a new variable and over here, or a new expression over here, which when used Feynman techniques will simplify the expression. Yeah, and you will also notice a beautiful usage of Feynman techniques in this integral. Yeah. So what are we going to do is, let us introduce I of a as integral from 0 to 1, integral from 0 to z of e to the power minus a ln of x by ln of x. So we are introducing this integral as I of a, and we note that I of 0 is the required integral that we need to find out, yeah, because only then the upper numerator goes to 1. So the first thing that we can do to simplify is to differentiate the expression with respect to a. If we do that, we just have partial derivative that we have to do, and we get e to the power minus a ln of x times minus ln of x minus, okay, so this is basically the numerator, yeah, minus a ln of x times ln of x by ln of x dx. Yes, now ln of x cancel each other out, yeah, so we just have I dash of a as negative of the integral from 0 to 1, integral from 0 to z of e to the power minus a ln of x dx. Okay, so now it has kind of simplified because we don't really have a denominator ln of x now, and this can be simplified, yeah. So it can be simplified to I dash of a is equals to negative of the integral from 0 to 1, integral from 0 to z of, this is just x to the power minus a, yeah. And kind of forgive me for a small mistake over here. After dx we also have dz, yeah, dz, 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 dz. Here also we have dx and then dz, yeah. So we have I dash of a is equals to integral negative of the integral from 0 to 1, and now this is x to the power minus a plus 1 by minus a plus 1, and this goes from 0 to z dz. Yes, again I dash of a is minus of the integral from 0 to 1. This is basically z to the power minus a plus 1 by 1 minus a minus at 0, this is just 0, yeah, and dz. Now it's kind of has become easier integral now that we can easily solve. Minus 1 by 1 minus a is over here, and integral from 0 to 1 g to the power minus a plus 1 dz. Yes, yes, yes. Now after this what we can say is I dash of a is minus 1 by 1 minus a. Now this is g to the power minus a plus 2 by minus a plus 2, and this goes from 0 to 1. Okay, so we now have idence of a is equals to minus 1 by 1 minus a, and then 1 by 2 minus a minus 0, so no need to write that. We just have product of these two expressions. Yeah, and sooner we might notice that this expression can be written in terms of partial fractions as 1 by 1 minus a minus 1 by 2 minus a. Is that 2 minus a? I'm probably wrong. I think it's the other way around. Is it? Let me see. 2 minus a minus 1 plus a. No, this word isn't wrong. It should be other way around. Basically 1 by 2 minus a minus 1 by 1 minus a, I guess. 1 by 2 minus a minus 1 by 1 minus a. If in this case we have 1 minus a minus 2 plus a cancel out, and that minus 1. Yeah, okay, this way it works. Now let's try to find its integral. 1 by a is just now ln of 2 minus a by minus 1 minus ln of 1 minus a by minus 1 plus c. Yes, and so we get I of a as ln of 1 minus a by 2 minus a plus c. Yes, and so now we just need to find c, and that will give us the answer. Now to find c, what we do is, notice that when a goes to infinity, this numerator goes to infinity, so integral also goes to infinity. We know that I of infinity is 0, so we'll use this fact. Yeah, over here, if I have to find I of infinity, this is just ln of minus infinity by minus infinity, which is 1. So ln of 1 plus c, that is 0 equals to 0 plus c. So this implies that the constant is c, is 0. That's why I of a is just ln of 1 minus a by 2 minus a plus 0. Yes. Now our required integral is when a is 0. Yeah, because it vanishes and we have the required integral. So let's substitute a as 0, and we get I of 0 as ln of 1 by 2, which is minus ln of 2, and this is our required answer. Yes, so we got our answer as minus ln of 2, and we have solved the problem. Now if we want to talk about the flow, we just do the definition, and then we had to carefully choose this function, which could be Feynman differentiated to simplify the expression. Yeah, and it's really most of the time, because this can give us our required function as well as at infinity it goes to 0, so it has uses in all large simplifications, and then it was just an easy power rule integrals. Yeah, and at last we got the answer using partial fractions, and that was it. So hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.